Group 2 is here to document our journeys of creating a smart trash cans, Barbie candies, a project that combines electronic, coding, and creative designs. Regardless of what the finished product looks like and how many challenges we face, the process has taught us many lessons and joys. Let's take a look back at how we created. First, before we actually build the main products, we plan and design the prototype in hard copy. This was to predict the overall size of the box, the placement of the sensors and lights, how the box could work, and especially how all the internal components could be positioned. Start thinking about real-world issues like whether the IR sensor could detect objects too quickly, or if there was a delay in response. Planning helps prevent these issues in advance to identify problems and find ways to solve them.
Each week, we also deliver progress reports through short classroom presentations. These regular check-ins were a key part of our workflow, helping us stay focused and on track with our project timeline. By presenting what we have accomplished each week, we would clearly see how far we'll come as a team and what still needed to be done. More importantly, these presentations gave us valuable opportunities to receive feedback from both our classmates and the instructor. Sometimes we were even able to catch small issues that we hadn't noticed before or gain new perspective that would help us improve our design and functionality. The questions and suggestions we often got during these sessions were incredibly helpful and were very useful in our development process. With the basic design and system layout in mind, we would move on to sourcing all of the necessary electronics components for building our smart trash can. This stage itself was really important because it actually laid the foundation for the actual physical prototype. So, we carefully planned out what we needed based on the functions that we wanted to include. For example, automatic lid opening, audio feedback, and also real-time display of the bin status. Our shopping list would include an OLED screen for displaying status messages such as bin full, ready, and an infrared sensor or an IR sensor to actually detect the presence itself of the trash. We would also include push buttons for manual controls and a DF player to actually play the sound effects of the voice prompts. We would pick up LED lights for visual indicators and a buzzer for simple audio alerts, and of course a microcontroller to tie everything together and to run the show. For all of this, we would keep receipts, invoices, and packagings as a part of our documentation process, as well as our reimbursement process. This turned out to be very helpful, especially for budgeting and cost tracking.
At first, we built a completely different version of the circuits. Before the holiday, we test some features like the lights turn on one by one for 3 seconds, then one random light stayed for another 3 seconds while the red light was on. The LCD showed which one, and thus when the player has to throw the trash into the correct bin, the IR sensor would detect it and show yes or no on the screen to count the score. But because we didn't have much time and the old design were difficult to finish, we decided, with advice from Professor Mindang, to remove the old circuit and delete the old code. We started a new version that's simpler, easier to finish, but still keep the main idea. For the new circuit, we removed the old wire and rewired to be cleaner. Before we had only one IR sensor, but now we use 3 IR sensors, each one connected to a different light. We also cut the DO wire from the NeoPixel because we don't use the special light effect anymore. Each light is now connected directly to a separate bin on the Arduino. We added a buzzer and an LCD screen with power and data right going into the breadboard. The biggest challenge was soldering the lights. The parts are very small, so the wire broken easily. Even though we reduced the number of wires, it was still hard to place everything inside the box. For the part of coding, we also changed everything. Before the sensor were the button of the ping, but the charge flew too fast and the sensor couldn't detect it properly. So now we have moved the sensor near the light so it can detect more accurately. The new code is simple. It's randomly turned on one of the three lights. If the player threw the charge into the correct pin, the area sensor detect it and the LCD show yes and the puzzle make a sound. Then the system reset and choose another random light. So we build the code step by step. First the lights, then the sensors, then the puzzle, and finally the LCD. Even though we have to train everything, we believe this new version is the right decision. It helps us finish the product on time and still keep the original idea.
First, I draw up the sketch of the final product. Then I list out things that we're gonna buy, including wires, boards, and many other things. Afterwards, I get to the testing phase. So the first part I test was the buttons. The buttons didn't work, and when I did get it to work, it sort of complicates the function of the product. So we sort of phase them out. And secondly, I test the LEDs. The LEDs also did not work, which prompted me to buy better LEDs with more functions and more color displaying abilities. Lastly, batteries. We need a power source, but we never got to buy all the necessary parts to make a complete battery tray to power up the whole thing. So we just decided to go with a more simpler, stable power source, which is an adapter. I tested all the parts and I concluded the required specifications of the adapter. I helped assemble everything, but mainly it was done by Gilha.
While assembling the mainboards, we also turned our attention to making the bin itself. We wanted to make sure that it wasn't just a functional but also visually engaging. We were inspired by the adorable minions, so we decided to embrace their playful energy as our theme. Unlike the classic minions with their one or two eyes, we wanted to add a creative twist to our bin, so we introduced Poppy Candy, a three-eye character that's both unique and fun. The process began with cotton format sheet at 5mm thickness, but we quickly realized that they were too thin to hold their shapes. To ensure the bin has a sturdier structure, we switched to 10mm formats and recut the necessary pieces. Once we had the right material, we carefully drilled 3 holes to form the eyes of Poppy Candy, making sure they stood out as our defining feature. With the core structures ready, we used hot glue to securely assemble the Formex elements. Then it was time for real transformation, the painting stage, where Poppy Candy would truly come to life with vibrant colors and a playful personality. With bright yellow and blue bands, we transformed the bin into a cheerful animated character, even adding a friendly smile to complete its personality. The result was fantastic. A bin that didn't just serve its purpose but also gave a sense of fun and warming to the project. And here it is, the final version of our gamified bin. Put your empty bottle and the IRD sensor detects it. The screen responds, the LED flashes, and the buzzer gives feedback. It was a long journey full of learning, mistakes, and fixes, but in the end, we're proud of what we built. Thanks for watching, and we hope this inspires your next tech project.